Okay, so let's continue from where we left off last time. So we got textures working last time. When I was actually thinking about, I thought a bit about this last night. I think it would be nice to just try and set the background color of this like fragment shader to the color in here. But actually doing that will involve writing the really simple command line utility that I want to do a bit later. So we might do that kind of towards the end of the stream. But the thing I want to do initially is correctly, for each of these tiles, correctly choose the segment of the image with which to display. So so let's get on with this. So we'll need to do this with regards to proportions. So currently the texture coordinates we're using are just kind of the zeros and ones as per the OpenGL, it's like the OpenGL book suggested, and therefore kind of what's being done behind the scenes. So we'll need to, let's bring this up again. For each of these tiles, we'll need to basically compute the coordinate of the top left of the tile and the bottom right of the tile relative to the kind of the inner border. And then once we have that, we will need to set we'll need to modify this draw color rectangle function so that it's just a so we're actually not blending the colors with the textures, it's just simply the textures. Perhaps that's the first thing to do. We'll create a different buffer instead of this kind of draw color rectangle that's going to the color buffer vertex. The color vertex buffer is a better name. We'll modify this to, we'll create like a texture one, get just like the plain uncolored textures loading, and then after that point, tweak the coordinates. Okay. So, where to begin? I think we should just create another VAO and start storing stuff in there. So we have the flat color one we will use for things like the borders. I think it makes the most sense at this stage yet to have one of these around. And then we'll want to do our, I feel like we should layer these in the order that things are drawn on them. Just call like the texture VAO, and then the texture VBO. And then we will need to set this up. So in compile shaders, we'll need to create some new shaders for this. So we've got the background shader, the flat color shader, and then we'll do the texture shader. And what do we want to call these? Let's just call them vertex texture and fragment texture. So if we go into our shaders, and then let's copy the flat color shader that's currently kind of blending both of these. Save that and then copy it out to a vertex texture.gsl. Let's just likewise open up the fragment flat color shader. What is the key? What am I doing? Save that. Fragment vertex fragment texture.gsl. And now that's in there. Okay, and now I think we should start modifying the let's see. Yeah, we need to start modifying these. So I think we should begin with kind of dropping the texture information from the first piece. Actually, we'll keep this stuff going. We'll keep all of this in here. We'll just check that we can. We'll get stuff set up so that we can still keep compiling it, and then once we've got like the data structures of all of these in the background, we'll then start turning things off and turning things on. So let's first. We need to embed these. Likewise, let's just order these background, flat color, and then flat color, we want to be calling the texture, and vertex texture. Let's, okay, let's just check these are compiling. Okay, 554. All right, we need to declare a global for these. Come on, graphics. Let's just start calling these like shaders, since we've already got 3 now. Texture shader. File not found. God, that was what we called it. Oh, I called it vertex texture. Vertex texture. Okay, great. And yeah, we can. Everything's going to compile the same since we didn't really modify it. Okay, so now we can start turning some things off. So, to jump back into the shaders, and we'll start. Like, how should we do this? Actually, before we turn things off, let's start drawing some stuff with this new shader that will then give us, we'll then have kind of like three draw cores. One is for the background. One is for the, let's see, we're drawing the background. One is for like the solid color things, such as the grid, and then the other thing will be for the tiles. Currently, we're just drawing the center part of the tile in the same draw core as the rest of the grid. So call it grid G. In this draw grid geometry, let's separate this stuff out, move it to something different, render that with this new shader, and then we can just start removing, like, since the shaders combined, we'll then be able to just drop the texture part from the color and then the color part from the texture shader. Okay, so a lot of this stuff is constant, so we can just factor this right out and store it, have the compiler remember it at comp time. Like almost all of this can be factored out at comp time. Let's do that. We'll definitely clean up the order of all of this towards the end. There should be a place for constants in here. Shader constants, or maybe just like constants, shader grid geometry. So yeah, the drawing the outer and the drawing the inner, these will still use the color, the flat color shader for that. For these rectangles, we do want to remember where these things are. We're just going to be drawing separate parts with them. Which is totally fine. We don't need to massively refactor this. Instead of like draw color rectangle, we'll just want like draw texture rectangle instead, and kind of do things that way. Okay. What's the line? Let's just figure out the line that we want to duplicate or do the different version of. So for all of the tiles in the grid, skip it if it's animating or 0. Yeah, construct a rectangle, which is the border, draw that. Okay, so this line here is the one we want to modify. Make this render a texture instead. Oh, it's not. We know what we're doing. We don't need to write an exclamation point. Okay, so we'll want to change this draw color rectangle procedure to let's put it after this. Just draw texture, and likewise we'll take in a rectangle. Since currently we only have one texture, maybe this is maybe this is enough. We can modify it if we need to later. So I think the concern here is that we'll want to pass in the coordinates of which texture parts to take. So let's say what's a good kind of API choice here? We could just say pass in the coordinate of the top left part of the texture and then the bottom right part of the texture. I feel like that's maybe it's just the only sensible way to do it. Because we'll need to be computing this stuff before anyway. Yeah, if we know the top left and the bottom right, we then know all of the other coordinates. We need to draw the triangle. So this will be enough. So we can say top left, or like texture coordinate, like top left texture coordinate is such a long name. That's fine. Top left texture coordinate, which is just the vec2, and then we'll have the bottom left, or maybe just TL. No, bottom left, bottom right texture coord. And let's just alias these with really simple names. TLTC is just the top left texture coordinate, bottom right texture coordinate, bottom right. Okay. So yeah, what are we gonna do? How are we gonna write this? We just need to figure out what the line is that we're like pushing to the GPU. So this will have a length of 2. Well, no, this will have a length of 4. We need 2 floats for the position of the vertex, and then 2 floats for the position of for the texture coordinate information. So so I think we can actually just copy pasta this stuff to get the coordinates of the rectangle. And then we need to compute the coordinates of the of like the texture rectangle. Or maybe just coordinates of the texture. So that's better. So I think likewise we should just have like x left and x right are slightly vague now. There's like 2 sets of coordinates that we're juggling. Provided we just remember, I think it's okay. I think we can juggle remembering this. We've already have a comment describing what it is anyway. But we need to come up with names for the texture coordinates. Maybe we do use this S and T convention. it's the first time we'll deal with it. So we'll have like S left, S right, and then yeah, T top and bottom. So actually now I'm thinking, is it worthwhile just actually passing in two rectangles where like the rectangle we want to draw, and then the rectangle of the texture we want to render. Maybe a bit nicer. No, because then we're juggling the screen space coordinate and the texture space coordinate. We'll keep them separate. Yeah, so by definition, the S left coordinate will just be the top left TC, or at least the first argument of that. S right will be bottom right texture coordinate 0 of that. And likewise, T top will be top left texture coordinate 1, and the T bottom will be bottom right texture coordinate 1. So then we can just start compute the nodes, which is complicated. The nodes will push to the GPU. So we'll want to push, we just want to push 6. Yeah, let's write a like similar like color vertex function, but this one will be like texture vertex. And at the same time, since we're here, may as well define this like texture buffer thing now. Okay, so we have texture buffer. We'll say texture vertex buffer. Texture buffer just implies something completely different. And then we'll say we have a texture vertex. And then let's define what what a texture vertex is. So yeah, we need the X and the Y, and then texture X and texture Y, and that's it. So we want to push, let's similarly create like a dummy function so we don't need to fill out the struct every time. Texture vertex 32, and then TY 42. Return texture vertex. There's probably some way to write this using meta programming in some way. Anyway. Okay, so back to the function we want to write. Yeah, we just want to set v0 to be texture vertex, then the xy, tx, and ty. In other words, x. What order are we doing this in? So yeah, we're doing v0, v1, v2. So yeah, x left, y top, and therefore s left, t top, and the others will kind of be the same. So here would just be s right, t top. This will be s left, y bottom, t bottom. That's that, and then this is s right, t bottom. And then once we have this, we'll want to push the texture vertex buffer index up by 6. And well, we need to actually assign these to the buffer. Part of this is similar enough. I'm like wondering if there's some way of factoring this out. Maybe too complicated. So yeah, it's just the texture vertex buffer, texture vertex buffer index. Set all of these. Move it up. So I've got this buffer, put lots of stuff on it. So now when we go back to the draw grid geometry, we can use this draw texture line, or almost here. So now we want this to be draw texture something. So we're still using this rect, but we now need to pass in the top left and the tx and the t. Yeah, the top left coordinate and then the bottom right coordinate. Yeah, this is fine. But what are those things? We need to compute them. Actually, we can compute them at a later stage. We want to just separate out the textures at this moment. So let's pass in some constants. So we'll start with passing in like 0, 1, and then 1, 0. 0, 1, and then 1, 0. Why did Emacs just disappear the screen? Actually, calculate the TR coords. Okay. Let's just, I was gonna say, let's just see if this compiles. we had a runtime error last time where we like where we like exceeded the bounds of the array because we were not resetting the color vertex buffer index. I don't remember setting the texture color vertex index to be 0. Good. let's also do this. Texture. It's good that my brain remembered that mini alarm bell went off. Yeah, let's just try and compile this and see what the result looks like. Well, what are we expecting? Since we're putting all of this texture information into a different buffer, we should still kind of see the same thing as last time. It's just that the stuff inside the tiles won't actually be getting drawn. So if anything, like the earths in the tile should be slightly larger, but should otherwise kind of look the same. Okay. Expected return expression. Should just be void, right? We're not. Okay, some unused local constants. Not using the tile color anymore, that is correct. Expected 7 args, found 4. Oops. Okay, good-ish. So why aren't the colors appearing on these? We'll deal with the like animated color one a bit later. I think it's because it's still doing the color blending, but now with like the background color for the tile, which is like the gray. Okay, this is why all of this are dark. Okay, good. Let's just see what we have so far, and then we'll push on. Yeah, started separating out. Who cares? Who cares about spelling? Separating out the Shakespeare didn't care about spelling. Separating out the the colors from the textures. But we need to start using this new VAO. Because yeah, currently this is not getting used anyway. So so in the setup array buffers, yeah, we set up the background, we set up the flat color. We now want to set up the texture VAO and the VBO. Okay, so here yeah, we can just create, we want to create and bind vertex array as well as a vertex buffer object. So we want to replace this with texture. And then texture stuff is important, but we first of all need to set up, we need to tell the GPU how to move separate out the raw data and pass it to the fragment and vertex shaders. So in particular, yeah, we'll need to yeah, we need to specify the data, since we don't know the length of it, which we could technically compute it ahead of time, but since we don't really know the length of it, we want to give it a null, and but at least tell it what the maximum size will be, and the maximum size will be that of the texture vertex buffer. Yeah, we now need to, with that data, separate out the stuff. So there's 4 floats per line. 2 on each. So we get those. Then yeah, then we get our. Then we need to save separately this blue marble texture. Give it a bunch of options. The stuff we did last stream, cast, etc. This temp we need to get rid of. Yeah, we don't need this anymore, since that's now been superseded by this line. So now we'll want to start just drawing the geometry using using these buffers. But before we do that, we'll need to yeah, we'll now need to like modify both of the shaders. It's also we're doing a lot of stuff at once that it's making me feel slightly uncomfortable. If something breaks, it may be difficult to figure out what. Okay, let's go back to the render function, and we'll currently disable the drawing the color geometry. So we want to get rid of, want to disable this to begin with. Instead, we want to replace it with our new texture buffer. Yeah, we'll then get this working, and so it's almost the same. Instead of flat color, we're using texture, which tells me I can. Ooh. I'm surprised that it flies in here when all the windows are closed. Reply flat color with texture. Oh, that was nasty. So yeah, bind these, make them, set them to be active. Use this texture shader. Not the flat color shader. Oh no, that's of course that's what we want. We need to actually edit that, but not right now. Make that active. Use that. Get the location of it. Oh, the color vertex buffer index, this here is not correct. We're now just using 4 lines. We want to use the texture vertex buffer, and here texture vertex buffer index, and then draw as many of them as there are floats. Well, no, rows. Okay. So now let's modify that shader. So now you need to modify both the vertex texture shader as well as the fragment texture shader. So get rid of this color here. We're just sending in the position and the coordinates. We're sending out the texture coordinate only. Normalize all of that, sure, and then the position is just the inverted one, and that's the texture coordinate. Over here, not taking any color coordinates in, and instead we are we're using this texture function but not multiplying it by any number, and that should kind of be it. Okay. Let's give it a go. Let's compile it and run. Haha! Excellent. Okay. So yeah, the once we add in the color, the other buffer, like the animations will work, but otherwise, this other shader of ours is working. And yeah, I'm now really tempted to change the background of the background shader to whatever black is being used in the background of the earth here. Okay. Cool. Let's just again just like preemptively save this. Made plain texture shaders. Okay, so now we can exit both of those, but we want to modify the flat color the flat color shader. So now we want to remove from this the texture information. Now we're just sending out the color. And then for the flat color shader, we likewise don't care about the texture coordinate anymore. We just want to output the color. That's it. Okay. So now we can reactivate this stuff. But instead, we want to modify the 5 here to the 70 to a 5, since we just have 5 floats each node in that. No need to activate and bind these textures, and so otherwise looks okay. Except for these comment names. This is draw the grid and tile borders. And then here is draw the grid or draw the tile textures. We can ignore this, like, and cut out this draw triangles. Okay, so in the vertex, in like the color vertex function, we need to modify this a bit as well. We now don't care about these texture coordinates. We can get rid of them. And what else? Okay, we'll then need to modify the color vertex initializer. Luckily we commented out the one which was working last time, so that's fine, and we can now delete those two. And is that it? Let's see, in main, is there any setup array buffer stuff we need to change? Yes, there is. 7 should now be 5s. I think that's it. Let's give it a go. Oh dear. Redeclaration of 4, 5, 6, 7, 8, 9, 10. Texture 0 location. Which one is this one? This is just in the render. Yeah, we don't need that. Another great reason why it's, I think, terrible programming practice to like call a function that it itself contains the result from like a function call that itself contains the result from like a function call. If you pack like 5 things in them, like this mistake wouldn't have been caught. Like it would have gone, oh, it's just like you're just calling this, and it doesn't matter that the thing inside is another copy path. It would just do it. It's like it's the more information you give the compiler in any competent compiler, the better the result would be. Okay, great. Okay, things are looking. Well, we've nearly got all of the ingredients to finish this app. We're nearly feature complete. So yeah, we've got 3 different shaders running, drawing stuff. We now need to deal with the animation issue so that the tile looks the same when it's moving instead of jumping. Yeah, but otherwise, lots of progress is being made. Like it's actually like it's so satisfying to be just like doing all of this from scratch instead of yeah, it's like it's not like how many lines of code do we have now anyway? Like it's not that much. It's like less than 1,000 lines of code, and sure, there's libraries in the background, but even so, like the image, like the image processing library we're using, not only did we write ourselves, but is like only 300 lines of code, including a bunch of tests and a bunch of comments. Like if you factor it out, it's like probably like 150 lines. It's like Zig is so good, you can just do stuff from scratch, and it's control of everything, and the code is still small. Okay, let's save this and then continue on. Yeah, finished separating shaders. Well, that's an unhelpful message. Finish separating color geometry from texture geometry in the shaders. Okay. Oh, there's like a README thing we have to do at some stage. We've been off putting that for so long. Let's see. I think it will be worthwhile if we just get a start on the README once we finish this animating tile render issue. It's at least mostly there, and then finally when we start tidying up the project, we won't have to spend like an additional hour doing the README and everything. We'll just bite some of the pain now so that it's less later. But first let us adjust the animating tile issue. Okay, so animating tile. Right, so we have this loop where we skip stuff to make it move in the proper direction. It is actually calculate the coordinates. Yeah, okay. So yeah, so this will need to change to render stuff correctly. This would just be a case of in like the draw replacing the animating tile rectangle with this one here. So this should be animating tile rect, and we can get rid of the animating tile color. I think that's it. Super easy bug to fix. Yeah, great. I think is now moving as expected. I'm wondering now if we should change the background of the grid here to be a different color. Like I wonder if white will be too stark. It might. I think it will be fine. Let's see. In our background shader, what were we using? We're just using like a pure white. So we could try. We could try doing that in the tile border color. Let's see. So instead of the grid background being light blue, we could make this just like white instead. What does this look like? So it kind of looks like this. It's funny, like it almost doesn't look white to me. It looks like it's blue-white, but I think that's just like the brain going, oh, this is like a blue-black, therefore something about how the brain's working. The white kind of is a bit too bright though. I feel like we want to make the border color slightly different. It's currently this dark gray, but what is it? Tar border. We can make it. We could really make it a bit lighter. In either case, since we're going to be modifying the texture, oh no, there's more spam. So much spam. So much spam. Yes, clearly we want to manage this one. Let's see. Where's like the block? Yes. Okay. Great. Yeah, in either case, we're going to be modifying the textures, so it's not as if the difference in color between the current tile border and the texture is going to remain the same. It will be very different. When it's different, whatever color we choose now could be different. It will look different, so we should delay that decision until later. But yeah, so let's just save it. Shouldn't really have adjusted anything. Made corrected tile animation render. Okay. So yeah, so what's up next? What do we do next? In terms of progress, the next thing will be adjusting the textures, adjusting the texture coordinates. But we need to do the README sometime. I feel like we should just get the README done now. We've been delaying it for enough time on stream that let's just bite this proverbial bullet and just get it done. Luckily, this is not the first time we're doing one, so we can just copy and use as a base stuff that we did before. So yeah, let's copy the stuff from the Sudoku puzzles. So readme.md, and let's see. So let's call this like sliding. Well, whatever the name of this project should be, kind of what we have it on GitHub as. So what is that? Is it? Here it is. So maybe we just. It's currently called the project. The repo name is sliding puzzle in Zig. So maybe just like sliding puzzle. Maybe simple sliding puzzle. Okay. So yeah, this is a simple puzzle game. Where the aim is to reorder randomly shuffled tiles back into what's the language used on Wikipedia? I'm curious to see. Okay, there is a page called that. Also, what's a tour puzzle? Oh, okay. Okay, interesting. So we can use pieces. The aim is to slide pieces, slide randomly shuffled pieces of a image back to their sentence is too long already. Where the aim is to remake the image, reorder the image, to like unshuffle, that's not right. Slide pieces to back to the original place doesn't really works, but it's not like the idea is you want to just like make the image whole again. Slide shuffled. We can get rid of like randomly shuffled. Shuffle this line. Technically, it's pseudo randomly shuffled anyway. Shuffled pieces of an image back to their image to form. Maybe just to form it, like to form a whole image. Maybe that's fine. Or like a whole picture. Or maybe like to their proper place, or like back to their, the slide shuffle pieces back to their, pieces, maybe just to form a whole image. But no, whole is like, there's literally like a hole in it as well. Maybe to form the original image. Shuffled parts of an image. Or maybe it is to make an image out of, or is to slide pieces to make an image out of tiles. That's enough. Sliding puzzles are a common type of grid puzzle. Information can be found on Wikipedia at that link. Okay. Let's just include a current partial screenshot of the game. It will be updated, but whatever. Placeholder. Let's see, in sliding puzzle, screenshot.png. Okay, that's there, and here you want to say, yeah, an image, and in development, like yeah, a screenshot of the in development. Okay, gameplay. It's make this as small as possible. Use the use the keyboard keys A, W. Oh, actually, do we still have, are they still controllable with Dvorak? Yeah. If we go back to like the usual keyboard, they don't work. That's okay, we can keep that, oh, hang on. They work regardless? Oh, interesting. Wait, what? How is that working? Now I'm confused. Did we use both of them? What? Wait, what's happening? Where's the... Oh, come on. Where's like the state? Okay, so in this process input function, why is WASD working even on a Dvorak keyboard? Okay, I guess it's because GFLW doesn't care what like the overall layout is, it just wants a position on the keyboard. Okay. Whatever, like, oh no, what are we doing? Let's just like kill everything. No. It's just clean state. Yeah, so we want to say use the Emacs, stop it. W A S D keys on the keyboard. Control the tiles with the or arrow keys on the keys on the keyboard feels like a bit condescending, but it's by using the WSD or arrow keys or arrow keys on the keyboard. Okay, build instruction, yeah, this is, okay, here we'll need to modify this slightly. In that currently we're using like a dev version of the Zig compiler, but the version 14 is coming out extremely soon, as in the next week. Where's the where is Andrew Kelly's announcement? February the 17th, yeah, literally in less than a week. So let's just say, what should we say here? So this is a Zig project that natively calls Prelude code. No, this is not true. Not true at all. That calls that uses 2 Zig game dev. What are we? Dependencies. Why don't we just say like almost all of the code of this project is written in C? No. Be even simpler. You just want to say this project can be built and run with the following command. Building the project currently requires a recent dev build of the compiler. What is it? Tested on Windows 11. We should say where the Z compiler is available from. We haven't tested it on other stuff. And then, yeah, we should write dependencies. Yeah, this project is written in Zig and uses 2 Zig game dev libraries, currently bundled with the repo. ZGLFW and ZOpenGL. And then, what should we say? Both can be downloaded. Or rather, they both are available on GitHub at here. And then we'll say, yeah, like once Zig 0.14.0 is released, yeah, these will be like so the current plan is like once Zig 14 is released, then we will figure out how to use like the hash stuff in the build.zig.zon file to actually just reference them from the internet, so that if anyone wants to build it, the Zig compiler will fetch the repos from the internet, and then we don't dependencies, and then we don't need to like bundle them with it. I mean, I'm still in a couple of different minds about that. Like I feel like in general, it's best when making software that if like someone downloads like a repository, that itself is all you need to build it. You don't then need to do like an extra internet call. I feel like this is especially the case if, say like you don't have internet and you clear the cache and then you want to build it again, and then Zig says, oh, I can't build it again since we stored this stuff in the cache but you cleared it. Oops, that is kind of annoying. Like I can think of several times where during travel I've been in somewhere without internet, and because I stored stuff locally I didn't have the cache issue, but if I we'll think about it, think about what to do. This project was originally built using Raylib 5, absolutely. That is not. The project was originally built with the Zig. Well, let's just copy the version again. The dev Zig path. Okay. I think that's all that we need so far. Not correct. We should add in a header to our main file as well. So let's do that. Yeah, let's do this. So if we go to the Sudoku puzzle one, I think we can just basically copy most of this in. And then modify it. This is a simple game. This is a simple sliding puzzle game. Solving the game. Should only take a couple of minutes. Created what? When did we start this project? In February the 1st. February 2025 to something, who knows. This project is built with the command zig build that. Building the project requires, let's put it this way. Let's save this string. I'm going to be pasting it a couple of times. V version. Get that. Well, yeah, this is fine. Okay, the source code of this is available where? Here. And was developed almost entirely on Twitch, obviously. Copies of this stream available there. Okay, we're not using the Raylib, so we need to change that line. This project includes copies of the Zig game dev GL, gamedev libraries, zglfw and zogl. So both are available on GitHub. Yeah, see the page above for full license. And then if you say like both libraries are licensed, well, have MIT licenses, right? Oh, this is just like, this is a folder. Yeah, I'm pretty sure we checked this and they were both MIT licenses at some stage, yeah. How do you spell license? Licenses. See the pages above for full details. Okay. Okay, now we actually have a header. Now we have a README. Let's just get rid of everything. Let's see. We should note on the README that the project is still in the process of development. Like maybe the very first line should be that. Yeah, added README sort of header info RTM. Okay. Let's have a look and see if it's here. Great. It's there. The link should work. Okay. 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 Tedious admin stuff. Or actually, this is more tedious admin stuff to do. But whereas this has the MIT license, we forgot or neglected to do this for the other stuff that we've made. We really should do this sometime. Would be good to add in an MIT license on this thing. We've done enough admin for today. We'll do this another time. Okay, let's get back to actually developing the game. So, zig out, sliding puzzle. So yeah, so we're doing texture stuff now. So we want to, I'm actually kind of tired and want to eat lunch. We can do like another hour, I guess. So we want to now yeah, let's do this texture solving problem. All we need to do is replace 1, 0 and 0, 1 with the actual tile coordinates. Yeah, stuck in. That line needs to be updated. We can probably get rid of this tile to color function. Okay. So how are we going to calculate these coordinates? Well, we know the overall width of the outer rectangle, since we are drawing that and therefore we passed it in. It's just called outer width grid. Outer grid width. And so we just need to calculate the x and y positions, or in this case the s and t positions, as a proportion of this outer grid width. Actually, I think the inner grid width is what we want to be using instead. I think we still want, we don't want the border to go over the image, we want the border to be like outside of the image. Okay, so we want to use the inner grid width. So we'll then need to calculate the position as like the arithmetic should be really simple. It should just be calculate the top left position, then take the delta of that with whatever the current top left position of the tile is. Normalize that by dividing by the inner grid width. And now you've got your value from 0 to 1. Maybe you need to like sprinkle -1 signs to deal with like things being flipped over with OpenGL. But otherwise, that should be it. I'm also wondering now if the image is being flipped over. It doesn't exactly look correct. Yeah, I think it's being flipped. It's kind of being flipped upside down. So let's let's get it up the correct way first before we do anything with coordinates. That's a bit silly. Okay. So what are we going to want to do? I think we just want to invert the y-axis, since we won't do anything with the x-axis. So we do want to be passing in 0, 1, and 1, 0. So the draw texture function needs to be updated instead. So this stuff needs to change. So I think we just replace the top with the bottom. Okay, now it's the right way up. Cool. Let's just add that in. Made image, yeah, made texture, and correct way up. Okay, so yeah, back to draw grid geometry. Yeah. So right, so for each, okay, so given that in the list, in this grid of tiles, the tiles are originally 0, 1, 2, 3, 4, 5, 6, etc. Like the byte value of the tile should determine where the thing, like what grid coordinates are being used. So in particular, yeah, in particular, it's so much easier just to like stare at it and get the information that way. So there are many things going on. We might have to break out a like sketch pad in order to do these calculations. Because yeah, we're not like there's a lot of buffer calculations needed here. Because yeah, the top left corner is gonna there's a couple of calculations involved. But there is a kind of symmetry in that the function that will calculate like the offset given the tile in the x direction will be the same as in the y direction. So and probably with the now yeah, once we calculate the top left corner, the bottom right corner is kind of like trivial to calculate. It's just tile width, and you set that on. Okay. So let's do the byte. Calculate the top left corner of the like texture top left corner of the tile. So you want to calculate the tile X position and like the tile Y. So we can say tile, or rather just like the x coordinate is, let's call it tile x and tile y. So the tile x is just the tile quotiented out by the grid dimension, and then the tile y is the thing divided by the grid dimension. And then from this we can calculate the stuff. So let's actually move this around. So yeah, so we want to have so there's a couple of things going on. There's like the width of this in pixels, and then we'll need to do the proportion to convert it to like the texture width. So so maybe like top left pixel there, like top left pixel. The thing is, if we're doing all of this in terms of length, we don't even need to like know the exact position on screen in terms of floats. Just you can do this with proportions. What should we name this? Top left. Maybe just top left x. So this top left x should be the tile x times, well, there's a couple of things we need to do here. We need to add in, what are all of our constants to begin with? So we have the tile width, the tile border width, the tile spacing, and then the grid border width. The third is not important, but the other three we'll need to use. So we need to add in copies of well, for starters, we always have one of the tile border width. But then for every like additional, for every tile x, we'll need to add in two other borders. Well, I think it's easier to read like this. Oh, we can just factor this out. It should just be 1 plus 2 times tile x times tile border width. Much easier to understand. And then, or maybe even actually 2x plus 1. Then we need to add in the tile x times the tile spacing, and then we need to also account for the tile width itself. So we can likewise factor this. Yeah, for each one we go across, we need to add in the length of the tile width plus the tile spacing. Okay, and then the formula for the tile y is basically the same, except the x is replaced with a y. And then using these, we now need to like normalize these in terms of like the widths, and then we'll get the overall texture x, texture y. So the texture x is now the difference. We'll need to calculate the top left position of the. No, you don't need to. It's literally just tx is the tlx divided by. Yeah, this is. I don't know why I was thinking this was more complicated than it is. The inner grid width. And likewise the ty. So now when we draw the rectangle, we're just drawing tx, ty, and here is going to be maybe this should be really called like TLS and TLT. No, we need X and Y. But we also need to do the bottom right S and the bottom right T. So the bottom right corner will be the top left X plus the tile width divided by the inner grid width, and then the bottom right T will be that. So we have the top left S, top left T, and then if this is wanting floats, we're going to have to convert them to floats. This is getting tedious. I think if we just do float from in, it should be enough. We'll see if we get an error. We'll see the compile errors we get. Oh, the top water width is already afloat? Oh, everything here's already floats, okay. That makes it a bit easier to deal with. in that case then, well, you may as well just make these F32s. I think that's it. Or not. 528. Okay, sweet. We need to fix the animating issue again, but yeah, things are shuffled. Wow, we are so close to finishing this game. Well, not really. We still need to do the logic and clean up the code and a lot of other things, but it's now like feature complete, basically. Okay, we need to do the animating tile section. Ooh, do I want to just copy pasta the code? I feel like it's easy to read this if we do factor this out. It's fine for the moment. We'll figure out how to deal with this later. Let's just copy pasta it. 528. Wait, what's happening? Why can't we just copy this? Oh, okay, I guess the tile here is actually what is it? It's just called animating tile. Oh, no. Okay, great. The game is now feature complete. But I kind of want to just like solve this now. Or we can do something, we can solve an easier version by changing the grid dimension to 3. Where's the grid dimension? It should be a constant. is so silly. Grid dimension equals. There it is. Okay. Okay, let's solve an easy version of this and make sure it's as we intended. Okay, I kind of want like that one. Here. Okay, we need. To move. I've never like solved one of these online, I think, before. It's always been like the hand versions. Okay, let's shuffle these around. We want to get like this one in the center. Wait, where's the 0, 1 located? Let's see. We move all of those around. Move those back. And then, oh, we've nearly solved it. Oh no, it's upside down again somehow. How has this become upside down? Okay, good thing we solved it before shipping it. Okay, yeah, how do we move this? So we want to like shift these around. Like, it will be dope when this is on the Serena. Like, we could totally program this on the Serena. Well, okay, like how do, like, there's only 2 more we need to move. How do we do this? Like, we just want to permute these bottom, like the 5 at the bottom. It's just doing that requires like a gap up there. So if we can make the gap adjacent to this one, but okay, maybe we shuffle them around like this. Aha, great. Puzzle solved. So is there any like incorrect visual stuff going on in here? It kind of looks correct to me. I can't see. It doesn't look to me like the texture is incorrect. So let's, well, aside from the image being upside down for the second time, so let's adjust that. So in this texture vertex function, I guess we want to replace the bottom here with top, and the top here with bottom. Okay, and then let's make it easier to test by making it a 2x2 grid instead of a 3x3 grid. Let's compile and run this. Okay, wow, easiest puzzle in. Oh wait, this is an impossible puzzle, right? This cannot be solved. This is an edge case, like who cares? But it's, yeah, it's funny now just realizing, yeah, that it's possible to make an impossible 2x2 puzzle. Let's actually just launch this enough times until it's actually possible to solve it. Will this one be possible? I don't think so. Yeah. Okay, that one was possible. Yeah, it looks to me like it's okay. Let's just try the 5x5 case as well. Oh Lord, this will take so long to do. No, absolutely not. No. That is too difficult. Let's stick with 4. But let's say like node. If set to some shuffles will result in an impossible puzzle if the grid dimension is set to 2. Okay, but otherwise the game is basically complete, which is great. So, but of course, like any development like in any game development, the stage where it's working is like done like 20% of the work. In our case, it's more like 60%, but the journey is far from over. So what did we do? Basically finished. Got the texture. Got the texture coordinates. Correct. Game is basically done. Time to polish. Get that on the internet. So I feel like now is it already time to update the screenshot? I don't think so. Okay, so what are the next steps? The next steps is to finalize the colors. I do want to set the background of this to be the black that's being used in this picture However, we've done so many tedious color conversions using, my first JavaScript program.js on the internet. We're just going to write our own command line utility to do it in Zig. That will save us time in the future. That really shouldn't take us that long to do, like less than 20 minutes. The hardest part of it will just be like reading arguments from standard in, which we haven't done before. But the math is completely trivial. And then we can set that. And then I think it would be good to then start to finalize the colors. And then we've also got some well, we want to like detect a win state and play some kind of like animation to illustrate that the game is over. Game over, like Jigsaw once said. So spoilers. So it's going to be so dope to have this working on the Serena. Like it's the ambitious game we're making on the Serena we will eventually create, but it's good to want to make something smaller first. Because we spend a huge amount of effort getting textures rendering, and I want to cash out from that. I want the satisfaction of having like a working, non-trivial piece of software, graphical software on the Serena, and this will provide it. Well, the 4x4, it's kind of taking its time. So much so that I feel like we should adjust the troll time. So for the LP value, we should update this from, was it like 100 seconds? The background change time. Let's change this to like, so it's 2 minutes, but I feel like 2 minutes is now too quick. Let's change it to 3 minutes. It's going to take too long on a 4x4 to solve this. Yeah, so let's get on with writing the tedious, but less tedious than JavaScript app to command line app to convert things. Okay, we want like this is like mindless, but like mindless in a fun kind of way. So it's like addicting. Okay, enough of this. Back to actually developing the game, or rather, in this case, developing a tool. So let's do. I kind of thirsty. Need a break. Yeah, I'm thinking. Actually, in terms of like the colors for this, yeah, what are we doing? There's this question of like what color should we use for the border versus the inner colors. Currently, there is like a border being rendered here, which is like a black border, but it's almost unnoticeable. And so now I'm thinking, is there really any point in rendering that at all? Like maybe it's actually fine just to have the inner rectangle here. It kind of looks neater. Like I think it looks neater in this way. Yeah, like if we set the grid border to be debug instead of black. Will make it way easier to see, of course. Like I don't think it needs to be in here. We could actually just set it to be this. If we set it to be this background color, which is somewhat close enough to black that it's more difficult to see. The game seems fine to me like this. Just having the border be this just another copy of like the tile separation. Like it looks neat to me. So yeah. So when I said like 60% done, yeah, we're gonna have to like clean up the calculation from the code where we're not drawing this extra border. We can take out that constant. We set it to 0 to begin with, and then actually take it out from the code. A bunch of other stuff. But okay, we'll do that later. For now, let's start making a new color conversion command line tool. So let's just call this like color convert, and I can do everything in Emacs. Why am I using command prompt? What do we want to call this app? Maybe just like hex convert, or like RGB convert dot zig, RGBA convert dot zig. So we say yeah, an extremely simple command line utility that accepts a color in hex form, e.g. FF00 EE, and prints out the normalized prints out the RGB values as normalized floats. Okay, so let's make this example slightly better. If it's like FF00 FF, that should really just come to like 101 FF. 1001.0. This way we can avoid having to touch the internet again when we want to do this. We can just copy, paste it on the ghosty or command line and it will work. So yeah, I have never had to use command line arguments from zig before. So let's figure out how to read these in. Read in terminal, maybe just command line arguments into zig. 2022. We're not using an allocator for this, come on. Just read it, just have a fixed buffer. Come on. Like what's the thing I used to get it? Okay, standard OS argv. Pre-populated. Oh no, this work on. Okay. Wait, what is the args? Maybe old as well. Like this may actually work on Windows. We'll see. Stupid dogs. Okay, Zig. Not mine, of course. Zig build exe RGBA convert. Okay. No, we have to use this args alloc. Okay, that's okay. We'll just use a fixed buffer allocator instead. I think we've used one in other projects before. Okay, let's say we do fixed buffer we surely used a fixed buffer allocator before. Really? Really? Okay. Great, here it is. This is what we want. Okay. Great. Okay. Yeah, so we want to do allocate and initialize this. And then I thought you need to call like fixed buffer allocator dot like alloc in order to actually start using it. Then this is May 2024. Yeah, I swore you had to say. You have to say like alloc is equal to like fixed buffer allocator dot allocator. Yes, we'll see. Like, people need to stop using general purpose allocators. Like, it's not. In 99% of cases, you do not need a general purpose allocator. Yeah, see, like, I knew how to do this. And then, okay. Error union needs try. Well, you don't need to try that if you just make it unreachable. If an error is returned. And then, okay, then now we can just print these. Dprint is equal to standard.debug.print. Args any args. Well, let's call these like, call it args to begin with. Okay, so zig run RGBA convert zig. Doesn't know what args are. Doesn't know what arg is. argv isn't supported on Windows. Use standard process args alloc instead. Yeah, that's why we are commenting out this code. Oh, okay. Huge fail, but oh, is 100 bytes not enough? Out of memory, okay. Surprised. Considering our... This doesn't look like 100 bytes to me. Okay, so now... okay, yeah, how is this stuff being stored? Some of these look like a string. Some of them not. Like, what even is the type of the args here? Let's look this up in the standard library. Process.zip args alloc. Okay. Let's see. Process must call args free on result. Why? But we also need to pass in args alloc. Okay. Refactor to only make one allocation. Okay, that would be good. Okay, so we're using standard libraries using an array list, a slice list. Okay. Where are we getting the stuff wrong? Right, it's args with allocator. Okay. Oh wow, this is a really non-trivial function. I mean procedure. Oh god, no, this is nasty. Oh, this is so nasty. This is like having to deal with. This is not fun coding. Yeah, yeah, I'm sure that. Oh, let's just see how bad it gets. Oh, this is what a total disaster. Hi, Uranium Cat. Oh my goodness. This is like, oh gosh. I'm so happy someone, David Dealey, went through this pain of documenting how command line arguments are passed across different operating systems. Oh, this is so nasty. Oh gosh. Oh, yuck, yuck, yuck. Okay. And then, yeah, some people worked really hard to implement all of this in the standard library. Oh my goodness. Yeah, I'm right. It's oh shit, right? Like, isn't this like a total disaster? Like I'm currently on a side quest where I just want to pass in standard arguments from something like run on the command line. I hadn't looked this up in the library, so I thought, let me have a look at it. And then I just started going upwards, and yeah, it's just thing that there's a lot of stuff. Yeah, there's a lot of stuff. Yeah, I'm not, yeah, like especially when I got to this part, it's like, this is relevant when dealing with WTF16 encoding, like, oh man, oh man, yeah, okay, alright. Okay, hopefully the first and last time we have to deal with that, so if we actually want to print out stuff with allocators, yeah, it's still unclear to me what the type of the args here is. So if we do args alloc, then oh cool, yeah, I feel like, well, I think you're part of the future, Uranium Cat. Like Zig, with every year that passes by, I see more and more evidence that I'll just say that C is going to die as a language. That like, C will always exist in some forms. So much C code has been written. But I think in the case where you're targeting modern architectures, yeah, I've been writing Zig code for a year now, and I always get migraines when I go back to learning C. Well, not learning C, just when I have to write C. It's I feel like basically all of the problems have been fixed. The standard library is actually like great. The project has so much progress. It's like the leadership is incredible. The technical knowledge that the compiler team has is just, it would be very difficult if you were like some external company and wanted to hire them. It would be very difficult to come up with a number. That number would be so high. Like Jacob Young's like technical expertise is like almost unmatched. Andrew Kelly's ability to, he's been working on it for like almost 10 years, right? But still like kind of knows everything. It's so incredible. Yeah, lots of hope. And yeah, and the ability as well, like the fact that it's like cross-platform, so much of it is cross-platform. Like, you know, for instance, like the case in point, right? All of this like reading command line utilities, like doing this for like any one operating system is like enough of the headache that you know, so many programming languages will not like bundle it all together. Like trying to make it uniform involves doing a lot of crap, and Zig hasn't avoided that. Like the crap has been done, but someone did it. It's in the standard library, and so luckily for us users, we don't have to actually, at no stage do I want to learn any of this. I'm happy that someone else has gone through the pain of learning this and made it possible for me to use. Like, yeah, it's Yeah, yeah, I guess it will become mainstream, like the more that low-level stuff becomes mainstream. Um, yeah, it's while I think software as a whole would be better off if things were more low-level. There is just like the amount of learning required for the low-level stuff is, well, it requires more. It requires more. Yeah, and I think this is the point of the open source. Like it's something where, um, like yeah, a large number of people can meaningfully contribute in theory. Like the contributions I've done of like, well, like yeah, it's not. I would like stuff like this is like a substantial contribution dealing with all of this stuff. I'm just having fun making some games, kind of getting stuff out that way. But yeah, it's and yeah, just having the compiler written self-hosted and written in Zig itself means that oh, I'm not sure I have Zig live. I don't think I have it installed on this machine, but it's like it's and like having like the compiler written in Zig, the standard library written in Zig, um, it just makes such a huge difference. Such a huge difference. Like even here, you can just like you can immediately sort of see the tests that are being run and how to call these things. It's so good. Okay, but yeah, back to just printing out the command line arguments. So we should do this by just by doing what? Yeah, we say for these args, we get an arg each time. Print it. Well, actually, let's modify this a bit. Let's print out just what the arg value, what the index is, and then print them all on different lines. Okay. So, okay. So the first arg is just, right, the path to the exe. But if I say like test1, test2, let's do zig build exe. Just convert. And now we can say like test1, test2. Great, and we are printing all of these out. Okay, so then what is the type of, what is the return type here? I want to know what this is. I want to specify what it is. Let's move this to the right of the screen. F function args alloc. Oh, okay. So it's just an array of now terminated strings with possible error. What are the errors it can produce though? Okay, let's just try and copy this. Can we still build this? Can we still compile it? No, yeah, it wants to know what the error is. What is this? How do we determine what this is? I feel like there's a lot of possible errors going on. Some are math related. Some are going to be array list related. I'm being a bit silly. If we're catching any error and declaring it to be unreachable, we don't need to know what the error is, what the type of the error is. Great. Okay. Okay, so that's the hard part of this programming done. So now we just need to pass in these inputs and let's actually print out. We can just do like a debug print. Yeah, let's print out like a usage. Usage string. So we just want this to be rgba.convert and then like ff00 ff. And we can just say we want to print out this usage string. And then let's also like test the number of arguments. I'm curious to see how Zig is counting these. Okay, if we build this again, and then say we do like 1, 2, 3. Okay, it is counting these as 4. All right. So if the number of arguments is not equal to 2, then we want to fail it and print out what the usage string is. So we'll say if number of args is just args.length. If the number of args is not equal to 2, print out the usage string. We may as well just combine it in a single string. Yeah, I feel like it's always better to have to make the new lines and stuff clear. But otherwise, we want to convert stuff. So we'll need to read in the second second arg. And in fact, we want to break it up into bytes. So yeah, let's just say like well, yeah, byte 1 as a string is going to equal args 1, 0 to 2. Calling this like byte 1 doesn't feel. It's first byte. I know, here's a better name. Red byte string. There we go. And then we can do, or maybe just R, G, B, and A. 2, 4, 6. A. And then we'll want to convert all of these to yeah, I mean, I guess you could like delete the 0 argument, but it's fine. It's fine in this. I don't think there's any need to delete this. Like, I'm just using a fixed buffer allocator. Like, it should be fine. But we want to convert these into integer values, and we're reading these as hex. So we wanted to say like the R byte is equal to standard dot. Well, we're going to be using a lot of these format functions. So Emacs, what are you doing? Why can't I go to the top? What have I? Emacs, let me go to the top of the file. Great. We want pass. We want pass in. I think this is standard format dot pass in. Where is it located? Fn pass int. Yeah, it is in format.z. So we'll do pass int, and from memory, the type, the string, and then the base. So we're passing a byte, the string, and then the base. Oh, we're doing it in hex now, so it should be 16. Now we want to do the same for the green, the blue, and the A. And then, this will possibly return an error, so we want to just fail the program if it doesn't pass, and then we'll need to actually do the math conversion. But I want to just see if these are working right now. Let's just print one of them. So we do. Let's try and see build this. Oh, of course. Oh, nothing's okay. It at least compiled, and let's say we do, yeah, like let's say we try and print 10. So we have like 0A, F. Great, that's working. So let's now do the calculation. So now we can just say the color as a vector This keyboard, I need to get a better keyboard. We want this color to just be screen, Arbeit, this, and then this. Okay, so now we want to convert this into a float. So we can just say, maybe just like call this color U8. The color F32 is just going to be a vector of F32s. So we can just cast this and say float from int color U8. And then we want to normalize this, so we want to say it's not really, maybe just like the final color, or color normalized. Color normalized is equal to the color F32. We're gonna have to do like splat stuff, but currently, you need to. It's a bit dumb when it comes to some splats. So let's just say like factor is vector for F32 splat. 1 divided by, you should know what this is, 1 divided by 255. So then just multiply this by the factor, and then we want to print it out. When we print this out, we want to print out in a way that's just really easy to copy from the terminal and paste into whatever we're doing. So now let's say we want to print out just these values separated with commas. Oh, we may need to I don't want this like printing some like huge thing, the float's printing with a huge number of decimal points. Let's see what it's currently going to print it out as by default. If we do color norm, say like 0, let me build this again. It's printing out as like 0E0. If I do F, will it print it out as a float? No. Let's just check the standard library for some examples of how to print this stuff out. If I do 0 point, there'll be some examples of how to print stuff in here. Great. So maybe using D is enough, but if we did want to print them to 3 decimal places, then this would be enough. Yeah, D colon dot 3. Okay, so let's just see what D does. It just does 0, which is helpful, but not exactly what we want. No, this is wrong. It shouldn't be printing out 0. It should be printing out like 0 point something. Yeah, I still think that the Zig format has good documentation. Oh, okay. I'm doing something wrong with the math here. Oh, maybe it is interpreting this as a 0. Okay, much better. Great. Okay, so now we're basically done. We just, let's alias this color norm. Maybe like final color is FC. So then we can do actually, let's say like float format is equal to this. And then in the string here, we want to just print out the float format, then a comma space, then another float format, then another comma space, then the final one, and and then we'll just end that with a new line. Okay, and then we have 0, that argument, 2, and then 3. Okay. Oh, forgot semicolon. Okay, finally. Okay, so now we have our command line argument. So never again will we have to use the internet when we want to convert a hex value to a float, a hex color to a float. So let's we may as well run like a release build of this. Build exe de-optimize equals we'll build exe, allow this. I'm curious. Okay, it did. So now we RGBA convert. Let's call this something different. Like color convert .exe. Actually, let's kind of remove the other. Let's clean this up a bit. Let's see. Let's remove that. Remove the PDB file and release and remove the other. Remove the .object file, and then let's copy this to like our software section. So what have we got in here? maybe like command line utilities, and then we can move it into here. Add this to the path. We want to edit this. Add that to it. Okay. Exit this, and then okay, now we should be able to just call color convert AABBCCFF, and voila, we can copy stuff. Great. Yeah, it's like it feels so nice to be able to just like okay, wait, let me try yours. 3CFF 49FF. Okay. Yeah, it works. Oh, this is uranium green. Oh, okay. I can test this in the game. So let's copy this, and then document, sliding puzzle. Yeah, we can add it to the background of our shaders. If we go to the our fragment shader for the background, yeah, I can call this one, yeah, uranium cat green, vec for this. And then in terms of the background, yeah, we can use this. I feel like I spelled this wrong. Uranium. Is this spelled correct? Uranium. I guess it is. Z current build run. And voila, here's the, oh, that kind of is like a glowing uranium green. But yeah. Okay, so side quest done. And so, yeah, we'll learn a couple of things, in particular, passing command line arguments from scratch. Something no one ever wants to do, but luckily Ziga's taking care of it. Yeah, so now I want to use this color picker to figure out what the the background color of this tile is. And so if we just if we take like a screenshot of this, say like green screenshot, and then open it in Paint. Where's the screenshots? Yeah. Okay. Where's the... I know there's like a command line utility for this that was used at some stage, but it's fine. Okay. Copy. We can go color convert this. There's what it is. Like literally, we wrote that program just so I could do that. Vec for space black is equal to this. So now, if we try and make the background space black instead. Let's get rid of this. Aha! It's yeah, it's not. Yeah, I feel like it matches. It's I can't. Yeah, it's. Even if there is some variation in the image as to what that background black is. It's like enough that it's all right. Okay. So yeah, I'm kind of hungry, so I think I'm going to stop streaming and get some lunch now. But yeah, thanks so much for stopping by, Uranium Cat. This was fun. Yeah, let's save what we just did. Git commit. Why is there something called green screenshot in here? We don't actually want this to be part of the project. No offense. Git add. That's why I always do like git status, because 99% of the time you know what's in there, but then there are surprises like that. Changed background shader color to be space black. Let's push that to GitHub. Yeah, my pleasure. And so yeah, if you want to see all of this code is always, all of my streams is always public. If you wanted to look up what I just pushed, what I was working on today, if you go to loaded/sliding puzzle in Zig, I need to update the screenshot. The game is progressed more since then. But yeah, the green color is I don't think GitHub has updated this just yet. Oh, it will be in a fragment background. Here it is. Here's the Uranium Cat green. So yeah, evidence for the future historians that you're on my stream. So yeah, have a good one, and yeah, have a good day. Bye.